welcome back. We did just explore factorizing by taking out a common factor. So that's where you find the biggest number that goes into both terms, or all three terms, or all four terms, or all infinite number of terms. That would suck. And take it out the front, divide everything by it, and it becomes smaller inside the brackets. Now we're factorizing by the difference of squares. So, yes, well, for us it was yesterday. For other classes it may have been before. When you were expanding something like a plus b, a minus b, it comes out as a squared minus b squared. Now we're going backwards. So let's have a look at some examples of this. I've got the examples here. So we're going to start off with example A. And we've got a squared take 36. So every time I see two things and they're separated by a minus and I don't really have that much else to go on, but I can see that either they are both square numbers or they can be turned into square numbers. Surds will help you here. I realize that this is a squared minus, well, 36 is 6 squared. So then straight away I'm like, well, that's something squared minus something else squared, so that must be a minus 6, a plus 6. If we look at the next question for this one, it's 80x squared take 5y squared. Now, the x squared and the y squared and the minus in the middle, that's telling me that we're going to factorize by doing the difference of squares. We're going to turn it back into something like this thing. But the 80 and the 5 are putting me off. But there is a highest common factor. Something does go into both 80 and 5. It's 5. So why don't I just take 5 out the front first to try and make my life easier? So I'm going to take 5 out the front. And then I've got 80x squared divided by 5. So 80 divided by 5, 16? Huh. Yes, because 40 divided by 5 is 8, and 8 is twice that, so 16. And we didn't take anything out from the x squared, minus, and now we've just got y squared. Okay, that's looking better, because 16 is also a square number, so I'm going to write whatever's inside these brackets. Oh, no, I just scribbled on it. I don't. Okay. Let me see if I can do this. I'm a genius. Highlighter. Well, I'm going to choose a different color. Look, pink. 16x squared take y squared. I'm going to write what's in that brackets as squares wherever I can. So we've got the 5 out the front. That doesn't change. 16 is 4 squared. X squared take y squared. Now we can see it is a difference of 2 squares, so we can put it nicely into brackets. We've still got the 5 out the front. So we've got 4x take y, 4x plus y. I just had to stop and think then. That's it. That's factorizing by a difference of squares. If I just flip through the textbook, yes, I want to do one slightly harder question. So let me give us a bit of space and I'll write it in black. Sometimes you'll get questions that look like I'm trying to pick the kind of hardest one I can see in the textbook. Yada, yada, yada. Ooh. Oh, that's mean. Okay. Okay, I'm going to do 9b. So we've got x squared plus xy squared minus xy plus y squared squared. So here, when we normally think of our a squared take b squared, this is my first term that's been squared, the whole thing in the brackets, and this is my second term that's been squared. So what we're going to end up with is the first term minus the second term, first term plus the second term. Just like, actually I should write the rule here. So if we had a squared minus b squared, then that would come out as a take b, a plus b. In this case, my a is my x squared plus xy. So I'm just highlighting it in blue everywhere. And my b is my xy plus y squared. God, someone could seriously think you were having a stroke if they overheard this conversation. My b is xy plus y squared. So let's actually do this. We've got it in this form on the left. Let's put it into brackets on the right. Let's factorize. So we've got our first term minus our second term. So our first term is this whole x squared plus xy. I'm minusing the second term. And I'm going to put it in brackets because whenever I minus something that's more than one term, I like to put it in brackets so I don't forget to change my signs, which means I want these outside brackets to be slightly bigger so they're obvious to me. Xy plus y squared. So that's my a minus b brackets. And then my a plus b brackets will be x squared plus xy. That's a plus my b is xy plus y squared. You may ask why I didn't put that second xy plus y squared in brackets itself. It's because we're adding it. There's no real need to when we add it. But when I'm subtracting, I've got to worry about signs. So it's good practice to use brackets. I'm going to highlight my a's as well, just so I can keep track. Okay, now I'm going to deal with this left kind of set of brackets. I'm going to expand this. You know when there's a minus at the front of brackets and nothing else, you're just changing the sign of everything inside. So these will both become negative. So that's my x squared plus xy minus xy minus y squared, x squared plus xy. Why is that coming up so? Okay, got you back. So what we were talking about, we'd had this one the same. We're subtracting this thing, so these both become minus. This one's all the same, so I'm just going to rewrite it. Plus xy plus y squared. Now in this left set of brackets, I can see I've got a plus xy and a minus xy, so I'm going to have x squared take y squared. Ooh, this is I like this question. You guys won't. I like it. So, why did that do that? So I've got my x squared minus y squared. And then in the right-hand set of brackets, can't really see it very well, we've got x squared plus xy plus xy plus y squared. That's 2xy, isn't it? X squared plus 2xy plus y squared. This has become such a more intense question than I'd expected. I'd expected to just be showing you guys that you can do this and then have this whole term as the first one, this whole term as the second one, and then yada yada. But have a look at what we've been given. X squared take y squared. I can obviously factorize that again using difference of two squares. Okay, let's do that. So my first term's x, my second term's y, so that's going to be x take y, x plus y. So this whole x squared take y squared has, oh no, why did I do that? Let me see if I can fix it. Ish. That whole x squared take y squared, let me put my brackets back in, has become the x take y, x plus y. And also, have a look at this thing on the right, x squared plus 2xy plus y squared. Hopefully that's shouting out at you after that expanding brackets day we had. Because if I had x plus y all squared, that would become x squared plus 2 times x times y plus y squared. See, this is why it's really handy. Having had that practice, we can recognize that when we see it straight away, that x squared plus 2xy plus y squared is actually x plus y all squared. I'll highlight that. But now look, we've got x take y, x plus y all squared. We've actually got 3 of these x plus y things. So we've got x take y, x plus y cubed. It's all in brackets. We're down to just x's and y's. There's nothing possibly more I can do. I quite liked that question. I'm glad I chose to do it. Enjoy these questions. I enjoy seeing, like, going from this and then this and then this and then seeing something like this. I enjoy it when that happens. It makes me feel very accomplished. I hope you enjoy it too. And I hope I was recording this video. I was not.